Hi, I'm Andrew Armstrong and welcome to the Back Office Show. Can you see what these are? Yes, indeed, these are cold hands. And the problem is, in the winter, you can like put on more layers, can't you? If you're working indoors, you can wear thermals, long johns, whatever it is where you happen to be. But you can't do anything from your hands. So if you actually use your hands on your computers and stuff, then there's no way of warming up. And I'm looking at these are my fingertips, and actually they look rather warm, if you all things considered, don't they? I mean, it's saying around 27 degrees ish. I'm trying to work out actually how to orient the camera. I've got this camera in my hand and it's kind of crazy. I'm not sure which way round it's supposed to be for up and left. It's all wrong. Maybe it's easier I just kind of move my hand around, but yeah. So yeah, that's probably a bad example, but that's fine. We're going to keep the FLIR anyway running, because what I thought I'll do, I'd quite like the idea of a heated keyboard or heated mouse, which is obviously ridiculous, but it's something that we can test. At least we can mock up the idea pretty quickly. So I've got a bit of breadboard, and I don't use breadboard very often because I kind of forget how it works. But I can see a plus and a minus track here, so I'm going to just hook those up. Now the theory goes that if you have, I remember like we used to have testers to test things for thermal stuff, and they were just built of those really thick industrial resistors in aluminium cans. So I've got some 330 through-hole resistors here, and I thought we'll just get one and we'll put some power through it and just see what that looks like. I mean, if you think about it, I think these are 1/4 watt resistors. You can see they're quite small. They've got different, the different thicknesses of resistor are their different power ratings. So maybe if you're actually playing with this, you might want to consider those bigger 1 watt resistors. And then you'll also consider how much power you want to pump through them. But I'm just going to pop one on that power rail right there. Nothing too complicated so far. And I've got bench power supply, which I'm going to set, I don't know, 12 volts I suppose, and we'll just turn it on. And it's drawing, it says 41 milliamps. I'm not sure if I believe that. But we'll put that there. And we're going to, I'll zoom in again so you can see what the camera is seeing. It's not the ideal setup using this this camera. It doesn't quite want to know which way round it is. I'll give you an example. See, my finger now is moving in the reverse vertical way, so if I turn it that way, left, right, yeah. Anyway, let's see if we can spot our resistor. Oh, we can. There's the resistor. And it looks to me to be hitting is that 80 degrees C? Ooh, yeah, it does. It's toasty warm. Nice. Now I know it says 80 degrees C, and if you touch something that was 80 degrees C, you're likely to get a burn, but because there's so little thermal mass in a single resistor, it's cooling down basically. But I can feel that. That's pretty good. That's pretty good. So again, 40 milliamps? Or is it 400? Don't know. It's very easy to do the calculation, by the way. You've got I don't know, all those I was going to say it's so easy. Yeah, V equals IR, power squared something. You know the drill. Any of you at home who has a bit of internet will be able to figure this one out. So now it's saying 76 milliamps. And now it's 112. And actually, as I'm plugging them in, I can feel them getting hot. So they are heating up right away. So the reason you want the higher wattage ones is that you can sort of run them at a lower power though than they can dissipate, so they won't knacker themselves out and burn up or start a fire or something. So be careful. So let's try that again. Let's look at. Oh, you can definitely see in the camera now they sort of are sticking up. Let me see if I can get this better. Sorry, let me just come on now. Oh, it's gone off. No, don't want that. Wake up. Again, this is sort of one of those things really why sometimes the actual real device is more useful than the sort of gadgety one. But yeah, it's a nice thing. These flare things are nice, slightly cheaper, but there are actually some cheaper sort of Chinese alternatives at the moment I've noticed on the internet that I wouldn't mind trying. So we've got our 5 doofers there, and I'm just trying to target one of them. So up and down is the wrong way around, as is left and right. Jeez, come on. So it looks to me about 70 degrees. So just going to hover my hand there. Oh, shoosh, that's hot. They are super hot. Now I'm going to turn the power down from 12 to... Ow, that would burn you now. I'd be careful of that, that's a bit burny. If I can just get it over 1 there. Right, I've made some sense of how I'm supposed to hold this, so now it should work a bit better for us. So I can actually aim it and hopefully keep it aimed on one of our resistors. So there we go. Now we're cooking. So that's 42 degrees, which is this one. And I'm going to cool it down by hand. And you can see it sort of just hanging around there. That's at using 4 milliamps according to my meter. In fact, I'm having difficulty even seeing it because it doesn't glow now as well as anything else, this sort of ambient thing. In fact, it's interesting because you've got this sort of shadow of heat going on here, and I think you can actually see the edge of the phone. The phone itself is giving off quite a bit of emission, so I'll put a little bit of a gap between the two. But yes, so here is the tip of my finger, and that's where a resistor should be, and you can see it doesn't even show because it's so cold. So I'm going to put it up to 5 volts. Let's see what temperature we get at 5 volts. There we go, now we're at 5 volts. And we can just about see that. That's coming in at 39 degrees. It's hanging around at 39 degrees and it's saying 78 milliamps. 40 degrees. You can't really feel that though. I think the thermal mass is eating this. So as soon as you touch it, you cool it down. So let's see how that works. So I'm holding this one, and then I take my hands off. If we can target it quick enough, we can see what it's cooled down to. So you can see it dropped a few degrees, right? It warmed up pretty quick, but it dropped instantly. So I'm turning that up now to, let's go for the full 12. That's coming up as 187 milliamps, and you can see now we're at the 70 volts. Sorry, 70 degrees C. And then I'm going to turn it right up. Oh, my current limit's kicking in. Let me turn it up to, let's go for the full 20 volts, shall we? Now that's 320 now milliamps. So you can see now that's cooking. Now we're cooking with gas. So yeah, that's pretty awesome. I think there's a lot of scope here. I think 12 volts is pretty much our maximum we want to run this at, and that's fine because I think 12 volts sounds totally reasonable. And there they are, they've sort of cooled down again. So I kind of want to come up with a design going forward. I'm not probably going to do it in this video, but I'll tell you my idea, and then you can tell me if it's sensible or not. I want to get 2 pieces of wire, so I'll probably strip these down or cut windows into them, and I want to just mount the resistors between 2 pieces of wire and then stick those between, I don't know, a couple of pieces of duct tape or something, so it's all like a self-contained tape. And then my idea is maybe I could put it on a couple of strips underneath my PC keyboard with a power supply, like a 12 volt or 10 volt, maybe with a knob, and just see if that permeates its way through the keyboard, hopefully not starting a fire. So yeah, let me know down below if you think that's a viable option. But yeah, there you go. Keep on resisting.